Okay, so another little screencast here to try to help you with your Algebra Skills Review packet, Systems of Equations, which I think is section 7 of your packet. A system of equations is usually when you've got a group of two or more equations and you're trying to find out what the values of the variables are that will allow each equation to actually work out. Our primary focus right now is on two equations in a system. So really what we're looking for is a solution to a system. Gotta be able to write. Is where the graphs intersect. So for us in this instance, we're looking for an ordered pair, an x and a y. When it comes to systems of equations, you have a couple different ways of solving. You can solve graphically, so we can solve by graphing. We can solve by using substitution. And we can solve by what we call elimination. I'm going to guess that these latter two options are probably the ones that we're going to use most frequently. Graphing is fine, especially if you have equations that are in y equals mx plus b form. Graphing can become pretty simple at that point. Most of us like to stick with the algebra and the art of solving equations, and so we stick with either substitution or elimination. So I'm going to show you a little bit of both right now. Substitution. So let's say we've got two equations here. We've got 2x minus 3y equals 12, and we've got y equals 4x minus 7. Substitution works out really well when you've got an equation already solved for a variable. So like in this instance, we can see that we've already got this equation solved for y. So what that allows us to do is the following. We can take what y equals, in this instance, the 4x minus 7, and we can substitute that directly into that y variable in the other equation. So when we substitute, we come out with a brand new equation that looks something like this. So we've got 2x minus 3. Here's where I substitute, and I put in my 4x minus 7. And that's going to equal my 12. At this point now, I'm in one equation. I've got one variable to work with. It's just x, and it makes things a lot easier. So if I finish this out, I'm going to get 2x minus 12x plus 21 equals 12. Combine your like terms here. We get negative 10x. If I subtract 21 from each side, I get negative 9. So I divide everything by negative 10. X equals 0.9. If I want to determine the value for y, I now take that value of x, go back to one of the original equations, and I can solve for y. So here I get y equals 3.6 minus 7, which means that y is going to equal negative 3.4. And so really what I know is this, that if I were to graph those two equations on the coordinate plane, that they would intersect at the point 0.9, comma, negative 3.4. So that's how you solve using substitution. Again, a real easy method as long as one of the variables is already solved for. In this case, like we had here with a y. Okay. Elimination says exactly what you're trying to do. You're trying to eliminate one of two variables. A lot of times we see this method used when both x and y are on the same side of the equal sign. For example, if I've got 2x minus y equals 6, and I've got 3x plus y equals 4. If I were to add these two equations together, notice what's going to happen with my y's here. I've got minus y, I've got a positive y. My y's essentially cancel out. And so now I've got 5x equals 10, divide by 5, divide by 5, and I know that x equals 2. So again, to find out the value of y, take this answer for x here and substitute into either equation. It does not matter which equation you substitute back into. If it's me, I'm probably going to go into this one where I've got 3 times 2 plus y equals 4. So I got 6 plus y equal to 4, which means that y equals negative 2. So again, if I'm graphing those two lines, that's my point of intersection. So one last thing I'll show you with elimination. What if I have all my stuff on the same side, but my variables don't quite match up? So notice that I don't have any variables that are the same. I've got negative 2y and positive y. My x's aren't the same coefficient. Nothing's going to cancel out when I add right away. What I need to do here is I can multiply one or both of my equations by a given value. Here's what I would focus in on. I'm going to focus in on my y's for two reasons. One, I've got a negative and a positive. Secondly, one of my coefficients is a 1. In this y variable right here, my coefficient is a 1. That's really easy to manipulate through multiplication. If I want to get rid of negative 2y, I need to be able to have a positive 2y. So I'm going to take this bottom equation here. I'm going to multiply by 2. So my top equation doesn't change. 3x minus 2y equals 10. My second equation now becomes negative 4x plus 2y equal to 8. Now if I add my equations together, my y's cancel out. I've got negative x equal to 18. Divide by negative 1, x equals negative 18. Again, once you have that, go back, solve for y using one of your original equations. In this case, if I did that, we should come out with y equal to negative 32. So hopefully that helps you out a little bit. It's going a little bit longer than what I was hoping, but hopefully you got the info you need. All right? Talk to you later. Peace!